about my costume. You're not wearing a costume either.
I'm not hating. I'm aware.
It's pretty hateful.
It's just, no, it's because you're so anti-costume.
I'm so anti what?
Anti-costume.
Oh.
Did you see Mr. Thompson's outfit?
Yeah, I said I like the costumes. He was
Yeah,
like,
it's like
I don't know why you're hating because you're not hating the costume. I was like, no, I'm not a hater.
I told him that he looks. I said I like your costume. Just the guy, Mackie.
Yeah, I don't know what it is.
When he
I figured that one.
I learned
What's the goal of it?
from I did not get my
From the
Halloween.
She has like long nails like this.
Where did you do it?
Little ones.
I go to bachelor party and then
Dark purple. She has
And everyone. Yeah, because this is
I can see a really specific X-Files episode of it's black and white, and I finally get to watch it. I'm so excited.
show us your color.
The ball round. I love
Which one? Circuit?
Have you seen that Peanuts? And this has got But anyway, this worksheet, I completely forgot to do it for a beginning class. Oh, did you get like this thing I had lacrosse last night and I was so tired.
What? OLC or O/C.
We were taking our test. Yeah, she did go. She gave me the first. Well, she gave everybody. So she gave it.
Maybe it's like, oh Lord Christ, and he's just shocked because he wrote so good. He's just surprised, you know.
It says this in the RC restate of that limited edition.
But it's okay because they have like a vision of
Oh, you got the.
like I didn't put people.
So I don't have a years for the ring. I don't know how to play it.
And they're called
Oh my god, I didn't do that. You guys have to
I
do
found a ring on
this.
the ground.
Wait, that actually just got me. I fully looked over every single one.
I know this yellow for. I don't know how.
Or here, yeah.
I was kind of I went on my back and he plays me, but the guy that did the thesis in the context, he copied my thesis and my context from my
That's
paper.
mine from my paper, and she got rid of it. I didn't.
She wished she didn't, you didn't.
Okay, good afternoon, guys. I need y'all to get out the circuit from yesterday, number 49, please. Or 39. 49? Okay, guys, y'all need to take a seat, please. Who's out sick? Okay, so what I'm going to offer here in just a second is I'd ask you guys to start on this circuit that you picked up yesterday. So I'm going to let you tell me if you have found some questions that you know you need help with. I also had you pick up the test review, number 50. Now, I don't suspect that you will get to number 50 today in class, but it doesn't hurt for you to pick it up, and then you have the option of chipping away at it over the weekend if you want to. What I anticipate is that we spend the entire class period on the circuit, but the circuit is what you should plan on having finished for Monday. So, again, I did not ask you to finish it, so I know that you're not done or almost done unless you just took it upon yourself to go above and beyond. So there's a good chance you might have found a few questions I could help with. So let's go ahead and take those on the board so everybody can benefit. And then I will let you work at your own pace once we've exhausted those questions. Now again, this circuit's not really test review exactly, but these are all great questions for a test review. On your test, you should anticipate something asking about increasing, decreasing, concave up, down, absolute max or mins. That's a repeat. Repeat, repeat, repeat. Local maxes, repeat. Inflection points, repeat, 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 repeat. So there's really only a few different things you're asked to do in here. Some of it, of course, you've got to approach a little differently than you do the first times. But I do have my old answer key. I did find this one. So I do know what the question numbers are for today. So which ones would you like to discuss on the board? Number 5. Alright, so per usual, if you did number 5, check the answer, feel good about it, got the right answer, then just pick a different question to work on for a couple minutes. This is question 5. The one that says answer is 0 1/3. Now, even if you know that you got past number 5 and you didn't help with number 5, make sure your number 5 is in the same spot. If it's in the same spot, your first 4 are probably fine. All right, number 5 wants us to find inflection points. Okay, so what is an inflection point? Okay, so if it's changing concavity, it's changing from second derivative being positive to negative or vice versa. And so when it's not, second derivative is not positive or negative is when second derivative is 0 or undefined. So again, you've got to know how to start these questions. Like you've got to know what an inflection point is and what the process is to be able to do these. But concavity has to deal with second derivative, so if they only give us the function, we will have to take the derivative a couple times. Again, usually these type of questions are going to be pretty friendly derivatives. I'm not saying that you don't have to do product rule and occasionally quotient rule, but for the most part, they're pretty easy to work with. So it looks like the second derivative is never undefined because I don't have any variables in my denominator, but 1/6 gives me a 0 second derivative, which means it is not concave up nor concave down when x is 1/6. And if it's not concave up or concave down at 1/6, that might be where concavity is changing, which is what an inflection point is. Now I say might because we actually have to test it. So x equals 1/6 is a potential point of inflection or inflection point. But the definition of an inflection point isn't when the second derivative is 0 or undefined. That's what I tried to help you catch with that Kahoot. That's a good step to start finding the inflection points, but inflection points by definition are when concavity changes. So if this is the place where concavity might be changing, pick something bigger than a sixth to plug into the second derivative so that you can see it's positive and it's concave up. Plug in something smaller than a sixth into the second derivative, see that it's negative, so you know it's concave down. And now you have confirmed concavity is changing at x equals a sixth. And this time that's all they wanted. They just wanted the x coordinate. So x equals 1/6. Okay, Wesley, did you get what you needed out of that?
I did.
Okay.
I accidentally wrote 6x squared instead of 6x.
Yeah. And I will say that when you do these number lines, if you feel like something's off, if you can tell something's wrong, sometimes you can just kind of get the feeling based on like how things are working out. Always go back and just quickly double check your derivative and second derivative. If you take the wrong derivative or the wrong second derivative or you solve for it incorrectly, then it is going to seem confusing after that because you're using wrong information. You're trying to work a different question at that point. Okay, if Wesley had this question, I assume there's probably at least one other person who had the same question. So is there anything specific about 5 you want to ask before I move it out of the way? Okay, before I go past that, how about any of the questions 1 through 4? Yeah. Number what? 4? Okay. Okay, so if you didn't need help with that one, that's great, but please make sure you don't need help with question 4 before you tune me out. 4 is on the top of page 2. Okay, so question 4 tells us the first derivative. Be very careful here. Sometimes they help us out by giving us some of the derivatives. They don't make us do it every time. When is it concave down? Okay, so not the exact same thing as I did on the last question. I don't want my answer to represent the same thing, but my process is basically the same. If I want to know when my graph is concave up and concave down, I want to test around the potential inflection points. And then, so inflection points can be found by figuring out when the second derivative is 0 or undefined. And I keep saying potential, and I keep trying to emphasize the word because it's not an inflection point until you see concavity change. So this guy's potential point of inflection, potential point of inflection. Again, I think that as we get closer to the test, you know, when you guys make your little sign charts and your concavity charts like this, consider adding more information. This is the x value, and here's what I think it is. You guys have seen me often like do, you know, I think x equals 3 is a critical number. I label it so that I can remember what that was when I was trying to use it. Okay, so again, 4 doesn't care about inflection points, but the idea that inflection points are the only place the concavity changes is such a big help to me because now I only have to test 3 intervals. Something less than 0, something bigger than a third, and something between 0 and a third. If I can see the concavity during those 3 times, then I know the concavity of the entire function because I know the concavity around every place where concavity might be changing. So maybe try plugging in -1. Make sure you're plugging it into the correct thing. Second derivative. This would be positive, so concave up. Something between 0 and a third, that's a little bit harder, maybe a fourth. So 4 times a fourth is +1, 3 times a fourth -1 is negative, positive times a negative is negative. Again, sometimes plugging in those values is kind of tough, but at least you only have to know well enough to know if it's positive or negative. Okay, and then it might be changing here, so you better test something bigger than a third. Like, I don't know, 1. Pick some, always try to pick easy numbers. Don't pick something that's going to be hard. So that would be positive times positive is positive, concave up. Now, this question really only asked about concave down, but notice I still figured out points of inflection just because that's part of the process. I can see concavities changing here. So x equals 0 is a point of inflection, x equals a third is a point of inflection, but all they want my answer to be is when is it concave down. And since I made this little sign chart correctly, it's about impossible to miss. From x equals 0 to x equals a third. Okay, Rory, is that enough there? Okay. Was anybody else going to ask about 4? Needs something more detailed than that? Okay, what else have you found thus far? 1, 2, or 3? Anybody have trouble with the first 3? Okay, then let me offer a little bit past 5. 5 was the last one that was asked, or the furthest one, I should say. How about 6, 7, 8, or 9? That would be halfway through the assignment. Do you know that you need help with number 6, 7, 8, or 9?
Can you do 6?
Sure. Okay, so if you didn't need help with the last one, please make sure you don't need help with this one. 6 is the very last question on the last page. And I can already tell that this one is going to be more of a pain because the derivative is going to be more of a pain. It's messier derivative, messier solving, but the overall steps and process should be the same. So as soon as I read, when is this guy decreasing? When is the function decreasing? In my mind, I know that happens when the first derivative is negative. So I want to find the first derivative, figure out where he's 0, test around that, and then I'm going to be able to see when he's decreasing. So for your derivative, you're going to have to use product rule. There's no way to rewrite this with algebra. Now, hopefully you guys got to at least question 6 in your homework before today, but if you didn't, make sure that you're listening to this, because at some point, you guys know, in general, not really, but in general, the questions kind of keep taking a little bit further and further step the further you get into the circuit. And this is going to be something that you have to do a couple times. The first step in finding increasing, decreasing intervals is find the critical numbers, which is when the first derivative is 0 or undefined. This is not very convenient for us. I can't quickly tell you what numbers make all of that equal to 0, and I can't, well, I can, but it's not very easy to see what numbers make it undefined. And the problem is it's currently written as 2 fractions. So way back in Unit 2, when we first started taking derivatives, you would have to do things like get a common denominator, and probably wasn't your favorite thing, but it's going to help us here, because if I force both of these to have this denominator, now I can think of the first derivative as one big fraction. And this is significantly easier to work with, because a fraction equals 0 when the numerator equals 0, and a fraction is undefined when the denominator equals 0. So looking at this, before I got a common denominator and squished it into one big fraction, I couldn't have told you -2 makes that equal to 0. So it wasn't a coincidence that we practiced doing some of that in Unit 2 so that it would be a little bit easier in Unit 4. Okay, so there's two critical numbers, and again, you certainly need to know what's important about them. Consider making your little line chart a little more updated if you're struggling. But critical numbers are the only place the graph might change direction. So if I can figure out the direction here, here, and here, I know the direction the entire time, and then it's going to be painfully obvious when it's decreasing. The answer is going to be super obvious. So I can try something bigger than -2. Since I'm interested in increasing, decreasing, I don't care if the slope is positive or negative, I'm plugging it into the derivative. I'm not plugging it into the second derivative because I could care less about concavity on this question. I'm not plugging it into the function because I don't care about a point at this time. So I've got the first derivative up here, and also here, and also here. So you can plug it into any of these you think is the easiest. I'm just going to plug it into this one. I would get 6 over 2 square roots of 3, which is positive, so that's increasing. If I tried something like -4, I would have a negative over, well, this is weird. -4 plus 3 is -1. What's the square root of -1? Okay, what's wrong with I?
It's not on the root.
Okay, so it's an imaginary number, which is perfectly fine to be imaginary number. Imaginary numbers are not imaginary, just bad naming. But imaginary numbers don't show up on a graph. And a graph, like saying when something's decreasing, you're trying to describe the graph. So it doesn't even exist over there, which means the graph isn't going to exist. In fact, if we think about the function up here, that makes sense. If you try to plug in a number less than 3 from the beginning, you get undefined or imaginary, which just doesn't show up on a graph. So this part of the graph is going to not exist. And then the last interval I would need to check is between -3 and -2. And this would give me negative over imaginary again. Oh, that was really dumb. What was wrong with my thought process there? Yeah, I didn't pick a number between -2 and -3. I picked -3.5. I don't know why I did that. -2.5 would give us a negative over a positive, which is negative, and when the first derivative is negative, it's decreasing, and I did all of that because that's what I was asked to find. From x equals -3 to x equals -2 is the only times that graph is decreasing. It's the only times the first derivative is negative. Okay, now I don't know if I still have this one in here, but I think this was from earlier this morning. Yeah, just to show them a visual of what I was just saying. If you were to graph this function, which, by the way, is perfectly fine. Don't do this to get your answer, but you're always welcome to do this to kind of compare your work and make sure that things are making sense. Notice, to the left of -3, it doesn't exist. You can't plot imaginary on an xy plane. Then it was decreasing from -3 to -2, which is what I just found, and then it never decreased again. So, graphing it, seeing if it matches up with what you've got should all be consistent. And of course, if it's not consistent, then at least you know something needs a second thought. Okay, I don't remember who asked for number 6, but is that good enough? Who asked for number 6?
Oh,
okay. Is that okay?
yeah.
Okay. Anybody else want something more detailed about 6 before I move on? Okay, how about 7, 8, or 9? Okay, sounds like we've gotten to the point where maybe that's as far as you've gotten. So let me give you a few more minutes to kind of keep working on your own. And then we've got about 25 minutes of class left. So I will be asking you to finish this for homework, please. So try to get as much done as you can in class, but in a few minutes I'll work my way around the room and then you can ask me specific questions if need be. Once again, I had you pick up the test review on the way in today. You do not have to do any of the test review between now and Monday, but you have it as an option. If you feel like this unit is harder for you and you're a step behind everybody else, you could work on the review ahead of time to get a step ahead of everybody else. Or if you just want to increase the chances of you doing well on our Unit 4 test, doing the review early so then you have more times to work on the stuff that still hasn't clicked. That's good. Go ahead. Yeah. I only have that. I can't. I have asked many times and not gotten anything from you, so. Not that. You don't get to just do that. Okay. There's a long answer and a short answer. The long answer is, if you want to do it algebraically, you have to know how to change an absolute value into a piecewise function. So let me show you a basic one. The most common one is the square root of x. You know what the square root of x looks like? Like that? Yes, I'm sorry.
Yeah.
I'm sorry, my brain is fried. So sometimes the equation is y equals x, the slope is 1 and the y-intercept is 0. Sometimes it's that, and then sometimes it's the opposite of that. And then when it's this is when x is greater than or equal to 0, and when it's that is when x is less than 0. If you write something as a piecewise function, then you can do the derivative of each part individually. The good news is you don't have to be able to do the derivative of absolute value functions for your AP exam. So what I would actually recommend for you in that question is not doing it like this, but instead thinking about what the graph looks like. So the natural log of x is a parent function. Do you know what the graph looks like? That's what you did. You don't know what logarithm graphs look like? Got any transformations? Oh, then do log graphs in algebra 2? Okay. So it's one I have over here that you can glance over there sometimes. Natural log of x is considered a parent function, and of course a parent function means we use it often enough. It's kind of nice to know what it looks like. If a natural log graph doesn't have any transformations, up, down, left, right, reflect, or anything like that, it will always look like this. Whether it's base E or base 10 or base 3, it looks like this.
So then you just reverse the ball.
Exactly. If you want absolute value, positive stuff stays positive, but negative stuff becomes positive. And then if you know the graph, you definitely know where the minimum is. So if you can figure out what the graph looks like, that's way easier. It's a lot less steps. And I think the very next question is similar to that, but it's not. Correct. You should include it in one place, not both, and not neither, because then there would be a whole graph. No, because it's dependent. See, if you change the absolute value sign, absolute value function into a piecewise function, what's the derivative of x? So the slope when x is greater than or equal to 0 is 1, right? That makes sense when you look at the graph. But when x is less than 0, the slope is negative. So it's like sometimes 1, sometimes negative 1, but you have to think of it like that because you're different. You don't get to just average 1 and negative 1 and say 0.
When x equals 0.
Okay, but on the natural log graph, what would you do? Because x can never be 0.
Or like natural log of 0. Or
I'm just saying, a natural log of x, the absolute value of natural log of x, you can't plug in 0 for x.
Right.
So that, I don't know how that would help there.
I was literally just wondering. Like if there's a easy.
So then it's just
If you could, for example, I think it's like a derivative, it's just taking average chain of a function. Just approach the derivative of the function using finite slices.
That sounds similar to something we'll do next semester. That sounds similar to integration. Because in integration, you basically take an infinite number of infinitely thin things to do all kinds of stuff. So, that, my guess would be that's based on what you're saying, that's the closest thing that I can think of. Hopefully we'll get to some of that before break, actually, before winter break at least. You carried your pumpkins around all day?
Yeah, I painted them during advisory and then she told us to pick them up at lunch, so I said there's We're just slacking. Doesn't show up to class and then leaves in the middle of it.
I'm just surprised she let her Chromebook go.
Oh, why?
I don't know. I would sabotage it if I knew how. I don't know how though.
Why can't it not be just change the language of the sentence?
Wait, that's
Natural log?
here you are.
Absolute values.
As long as you don't have to change your letter.
Oh, it can be zero. That can be zero.
Yeah, I was just saying what language, why can't
So
it
we do the positive, positive,
x
negative.
is blah 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 or equal to x is greater than and like why can't they both be greater than or equal to and?
They do have the same value.
Since it wouldn't be a function if two values of the same value.
We both did it.
Yes, it's something, it's, sometimes in mathematics, we have like, we define things certain ways that like, just so that we all kind of agree on things.
So it log
And that's one of them, but yes, it's kind of like you're counting that point twice when you do it that way. And so you want to be sure to only include it once. So, I don't know like the mathematical, I don't remember the mathematical definition to why, because what you're saying makes sense
No, that's on the bottom.
in normal terms. I mean, it's just like the more common ones that students often think of. It's like, what's the square root of 25? Positive or negative positive? Not positive. And no, it's not. It's not because of how it's defined mathematically. You're thinking, what number times itself in the next 25, right? It's 5.
Well, let's pretend it's
5.
in the middle of 7th
But
period.
when we talk about the square root of x, we're actually referring to the principal, it's gotta be the principal square root function, not whatever. Which is, since we want it to be a function, we want it to have a horizontal. So we all just agree, we're gonna use the principal square root function, and we're only going to look at positive. So that's one of those times where it's like, you could kind of make an argument, but somebody has to put it down on, in the math definition to make this all kind of good sense. So I would think that's probably. Well, the good news is you don't have to. The long version is without the short version of the long version. You can change the absolute value of the piecewise function.
Like, my mom's so
And you
chill.
can just do the derivative.
Because I didn't say it out loud because there's the other answer. She's like,
But you don't
And I
have
was
to be
like,
able to do that for our
this is like
I would just use the graph section. You know what x squared is? Right? What's the minus 4 gonna do?
yeah.
That's if you're subtracting 4 from that. That would be like x minus 4 squared. This would shift it down. So that's gonna look like this. But then you want positive values. So stuff that's positive stays positive. And stuff that's negative needs to flip over and become positive. So then when you see the graph, you can look like that. You can see what it's going to have. Does that make sense?
What's your number? Since there's a number in front of A.
Right.
All those two.
You said you just swapped it.
Because you don't have a space on top. I don't know how long it's been on John transformation.
It goes under.
X squared is the most common variable. I know what this looks like.
So you have the
For
floor
outside of X squared, just go down 4. That's what this looks like. And then, all I'm saying is, to be able to just look at the graph.
Monday feels like it was like 3 weeks
Look
ago.
at absolute value. And absolute value just means everything's positive. So what's positive stays positive. This is like how it's stuff that's negative becomes positive.
This is an enclosed area.
And now you've got a visual, which is way better. You can smile. You can see when it's going down.
So if you want me to do it, if you want me to do it.
Thanksgiving is a holiday, but like I mostly just want to and I'm really curious.
So 1/3 is that.
This is funny. I don't know how to do that.
I'm gonna see if that's.
It goes from red.
Thanks, Philip.
It was like.
That is true, but I feel I don't think it's gotta be true, because this would be. Okay, where are you going? You're just making that
He's like standing here alone. In the answer. And I was like, I know she knows she's last now she's in the bathroom. He was like, I'm surprised she went in here over there. He's like, because I would totally sabotage him. So then I had to.
That's
So that you can really just say it. But he knows how to change it back, so it's okay. If I had disclosed it, I know, I was worried about that. I was worried.
Like, it was like one week where I was so busy and I had this whole technique about this test. Of course, 2 weeks afterwards.
You're gonna have to sign back.
Yeah, it's
He's like, I totally sabotaged if I knew how.
You will. We still have so many things left to do.
And I just walk in. When is that?
That's fair.
Mr. Johnson, did you put on a computer in manual?
What happened in
Huh?
He said,
I don't know how to do that.
I didn't do it. Why would you blame me?
No, I'm not blaming you. I said it. I had tabs open, guys, and they're all in
You put the idea in people's heads. You're like, I
I
would.
can't understand my whole computer, all my tabs are advanced.
I don't put calculus in that. When you walk past it, you're like,
Well, I'm
I
just
would
I'm so
sound like
Christian, and so I like always help out.
I didn't do it.
But I don't.
I don't understand this because I thought if it was equal x, it couldn't equal 0. I guess, so how is it gonna equal 0 if it's equal?
Well, if x is 0, all of that goes to 0, and all of that goes to 0. So when x is 0, why don't you factor out the
Okay, delicious breakfast though.
Oh, that's it.
And like, I remember the surgery with the apple, and I was like,
Okay, I'll remember that.
do you happen to have a band? I'm gonna find it.
Mine.
Do you
I do.
Did it taste good?
If I look at this, I look at this today, it's
So for what?
This morning, I would be easy enough to wire it and have
Okay, but it was.
Okay, all the arrows point this way.
funny things called.
Sorry, I just think it's like,
Okay, well that's just a basis.
yeah, it's not my fault.
I don't know how you could tolerate it all day. If I get a cut on my hands, like, I need a Band-Aid on there. Like, I need the pressure
I have
because
the
it drives
Band-Aid,
me
it
crazy.
just falls
Every time I wash my hands, like, it stings.
I can't cook it, but like I don't like the way it feels. I
Oh, I
like to
do.
touch.
I like to like pull it tight so like it like hugs it. It makes it stop hurting as much.